Okay, so for this section, I'm going to be going over how to do our Lab 2 measuring strain. When we last left off, we were starting to fill out this table where we were measuring the angles and the lengths of fossils from our back page. So our first part, we are going to find the orientation of line A. This is going to be the orientation of the fossil, and we measure it. We measure the acute angle between the flat edge, line A, of the fossil, and the long edge of the page. So to do this, we use the grid to help. We want to do the acute angle, so that is the smallest angle. So here we line this up so it is parallel, the edge of our protractor is parallel with one of our grid lines, and we measure off the angle, which here is about, so this is 10, about 14 degrees. So 14 degrees for this one. Here again we want the acute angle, we want the small angle, so we are going to line this up here and measure the small angle here, which is going to bring us to about 60. 60 degrees. And one more example, again our acute angle. So we will go up here, measure our acute angle, which is about 44 degrees. So you do this for all 15 samples. You write them in to your table here, and that will give you your orientation of your line A. Don't worry about this yet, so don't go down to section B until you have completely filled this out. Next, we are going to figure out the angular shear of our fossil. This is going to be the orientation from the middle of our fossil 90 degrees up. That is our original orientation. And from that original orientation, how much deformation has occurred on our B plane. So we want to make sure to count to the middle one. Right, so on our original fossil, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 little tabs. So if we want to find the middle one, you count to the middle of the sixth one. 1, 2, 3, 4, 5, 6. And that is where we're going to find our trident. Okay. So we line our fossil up, our protractor up to the middle. We have our sixth one. So we take this and measure it out. And that is going to be here, which again we're going from 90. So it's going to be 90, so 10, 20, 30, 40, so 50. So our row for this one is going to be 50. All right, so then our next one, if we go to 2, again, we line it up to the center of the fossil, go over 6, so 1, 2, 3, 4, 5, 6. So we want the middle of this one. Bring our ruler here. We go to here. So this is going to be 10. Here, so 10, 20, 30, 42. Our theta, or our trident here is going to be 42 degrees. We'll do it for this last one. All right, we measure it up, line it up with the middle of the fossil. Going 6, 1, 2, 3, 4, 5, 6. Take our ruler right in the middle of that. So that brings us to here. Which is 10, 20, 30, about 38. So row for this is 38. Now again, you keep doing this for all 15 samples, and you put your values into your angular shear diagram, lining them up with the fossil numbers 1 through 15. Now we want to determine the length along A. We're going to be measuring that in centimeters. Remember, A is just our straight line along the bottom of the fossil. So for 1, again, we're going to be doing, well, my protractor is millimeters, so we'll convert. So we've got 1, 2, 3, 4, 5, 6, 65, 66, maybe 67 millimeters. So we'll put that here, 67 millimeters, which is 6.7 centimeters. Okay. Same thing with 2. I want to measure the length. So that's 1, 2, 3, 4, 44 millimeters. Sorry, 4.4 millimeters. So you guys calculate that out. I can't do it on my head at the moment, but that's the idea, and you do that all the way down. I've done this assignment 4 times now. I don't know why they have this. We don't need this for any part of this assignment, so don't do length along B. And your shear strain is something you just calculate. You take the tangent of your angular shear, which you arrived to earlier. So this is how you do part A of the assignment for our shear.